No, it's that intolerant. It's that intolerant.
We're doing the same stuff we did, was it yesterday? Except they're just going to be harder problems this time. I talked like I could not do this with you, and then really the way I feel about it, I think what happens is my heart's just not in doing something only part of the way. So I feel like if we're going to do this, let's do it. So today you're just going to see some harder ones. They're gonna still involve the same factoring skills that you've already got. The level 3 has one extra skill that I didn't want to talk about. So when you see your new Delta math, it'll say multiply rational expressions level 2, whereas yesterday's assignment 46 said level 1. And so you'll see a pretty significant jump. I mean, the problems, I don't know, some of them look a lot harder than others, but I conjured up 4 examples for you. Let's see if we can knock this out. And then tomorrow, I would assume will be like a work day. Maybe I'll throw a practice quiz at you. We'll see. Maybe I'll save the practice quiz to Monday. I don't know. It'll be a surprise. I did not realize when I wrote this problem that I wrote 4 binomials. I think I was distracted watching the Dallas, Minnesota hockey game last night. So, yeah, I can say this on my recording that I'm really happy that the Wild won because Dallas has been the reason the Avs don't advance for a while. And so let's get the stars out. All right, let's go. So let's talk top left first. So I'll color code them for your educational convenience. What do you think about that top left? Yeah, what is it? Do better. 3x. Good. So we're going to take a 3x because every number in the red egg can be divided by 3, and every number or every term in the red egg has at least one x. And so we're going to take out an x. And then that's going to leave us with what? Nice. All right, let's head here. I'll just kind of build the structure of this as we go. Like this. There we go. And then what's the purple going to be?
It belongs to.
We can pull out a 2, and I'll just kind of do this off to the side. So if I pull out a 2, what's left? Oh, that was not a good answer at all. Let's x squared minus 16. Good. And the reason I didn't want to write that down below is because this one's not done. So I think this is sort of something new. This is kind of where level 2 separates itself, is that you're going to do multi-step factoring. Nothing gnarly, but it is going to often be multiple steps. So what is x squared minus 16 break down into? So use the difference of 2 squares. Good old classic difference of squares. So this lower left is actually going to be 2 times x plus 4 times x minus 4, right? All right, I'll switch colors again. Let's go up here to the green. What's that? What kind of factoring are we thinking there? Yeah, pull out your GCF again. So because they both can be divided by 4, we pull out a 4. And because they both contain at least one x, we pull out 1x. And then what does that leave behind? X plus 1. You're fine. And then let's head down here to the far southeast corner. And what are we thinking there?
Can't you just subtract? No.
They're not like terms. We can pull out 5x cubed. And again, spoiler alert, I'm not going to write it down below because of what you're going to see. So what I'm trying to get across to you here is that doing one step, sometimes it's enough and sometimes it's not. So what's left when you pull out 5xxx? How many x's are left from the x to the 5?
X squared.
2 are left. And what's left of 5x cubed?
1.
Yeah, 1. Remember, when there's nothing left, you have to put a 1 to hold the place. So what do you see again?
So if you distribute the x's combined and they don't multiply, right?
They add, right?
Okay.
That's an old property of exponents. Yep. So like when you pull something out, you subtract, right? Yeah.
And then we just have x plus x.
Right. Yeah. So Parker transitioned quickly into answering the next question, which is that this thing is a difference of 2 squares, x plus 1, x minus 1. So my lower right is 5x cubed times x plus 1 times x minus 1. So you can see, I think, a lot more work already, right? On the front end of this. The factoring is just a step up. And now that I can scroll all this off, I don't need that anymore. Now it's just time for what we came here to do, and that is just to cancel stuff out. So you can start naming things and I'll start crossing them off. I see that x minus 4 and x minus 4, x plus 1 and x plus 1.
Did you cancel out 4x and x plus 4 or no?
Oh no, not unless you want to have the math gods strike you
You
down.
can't take the X off the 4.
Yeah. So, I mean, what you start doing at this point, oddly enough, and this caught me off guard when I became a teacher, is that this tends to be the part that's the hardest, which I guess in hindsight it makes sense, but like it surprises me. So, what I found to be a good strategy in the past is just to collect things. So, I call this like a cleanup stage. And so, what I'm going to do is I'm going to take every survivor and just kind of collect it together. You don't have to do this. My experience tells me that bringing random messes into one pile is going to help us make more sense. So I'm going to take any survivors from the top, the 3x and the 4x, and I'm going to bring them together to make 12x squared. I get that that seems weird, but I also just want you to know that from the other side of this, watching for 20 years, watching kids try to cancel out. So I get rid of that one and change that to a 2 and then change that 2 to a 1 and take out that. It's like it gets really hectic for me. So let's just collect up all the pieces. And on the bottom, we have 10. Bless you. You would agree if we take the 2 and the 5, we have 10. How many x's do we have on the bottom? X cubed. And then on the bottom, we do have some excess pieces, right? We have x plus 4 and x plus or x minus 1. But I'm not interested in those parenthesis ones, the binomial factors. What I'm interested in is just how do we tackle the first ones. So, I mean, just be patient with this. Just like a fifth grader would do. How would you reduce 12 and 10? Divide them both by 2. So you know your answer has a 6 and a 5. All right, so that takes care of the 12 and the 10. And then what do we do with the exponents on the x's? Yeah, I mean, there's a lot of different ways to say this. I mean, you could take x squared out. You can use an old ninth grade property of exponents. You could do 2 on top minus 3 on bottom. 2 minus 3 is -1. So, you know, you have x to the 1 downstairs. Or like Landon said, literally divide them both by x squared. I mean, I would hope you would all understand that if you have 2 x's on top and 3 x's on bottom, I don't feel like you need a math degree to understand that there's one left over and it's downstairs, right? Good. So that's the way I like to do it, is kind of deal with all the big stuff first and then recollect and then do a simple cleanup there at the end. And then, so my answer, I knew there'd be a 6. I knew there'd be a 5. Now I know there's going to be an x. And then these extra ones, the x plus 4 and the x minus 1, they go down there. And the only thing I would do to make this answer better is I would probably take this 6 and make it not look weird off to the side like that. But who cares, right? Good, good. Now let's go again. Round 2. Right. 8x to the 4th minus 288x squared. So when I wrote these, I was pulling them not directly out of the Delta Math assignment that you're going to have to do, but I was kind of trying to write problems similar to them, like size of numbers, structure of polynomials, stuff like that. And by the way, you're not going to see any division in this next assignment. So I'm just going to, I had this one on my note card as division. I'm just going to dot flop it and change it. So assignment 47 is all times. So you don't have to worry about the upside down. So I'll flip this for you. As you know, we're not canceling anything right now, right? That would be a terrible thing to do. So we're just going to go patiently one at a time. Let's start with the red.
Oh, square.
Yeah, you can pull out an 8, right? And I mean, Parker, that's good instincts. Like, it's a good thing to like say, I hope, but your instincts are correct. So I'm going to take this top and I'm going to pull out 8. And I'm also going to pull out as many x's as I can, which is 2. And what's that going to leave behind?
X squared.
X squared minus No, that's too much. 8 times 40 would be 320. So it's got to be 30 something.
36.
Yeah, it's 36. That's good math because 8 times 30 is 240, and then you need another 48. So you add that 6 on there to make your 48. So
No, no, just brush cheating.
I think that Landon did that without a calc.
Not there yet.
I don't care if you use a calc. Let's not calculator shame each other. It's a little harsh back there, Mr. Political Hoodie. That's not done, is it? So for the second straight problem, you see that there's still meat on the bone, right? Yesterday it was all just, you take one bite, throw it away, take one bite. This is like keep biting, right? What is that second red thing going to be? Good. So it's going to be 8x squared times x plus 6 times x minus 6. And that is a fully factored upper left-hand corner at this point. There's nothing else you could do with that. Okay, so the red one is done. A lot of work, huh? Purple. This one will be a little easier, I think, I hope, but maybe not. Maybe they all kind of suck. Yeah, let's try pulling out a 4x. What does that leave behind?
X
Squared.
X plus 5x. Minus.
And yet again, we look at the remnants of our work and go, hey, look, hot dog. Surprise, there's more work to do, right? So this should be, I mean, you got this, right? If you need some practice, just reach out to me and let me know and I'll help you, okay? We want to lock this in, these trinomial factors. What is the bottom purple going to factor into?
6.
X plus 6 times x minus 1. Good for you. So we're going to change this to x plus 6, x minus 1. Good. It's quite a journey, isn't it? And then let's head to the upper right-hand corner. I think finally we got a snoozer here, an easy one. What are we going to do with that?
3x.
Just pull out 3x. Es el mejor que podemos hacer. What are we left with?
X minus 1.
X menos uno. Ah, that was a nice little break. Got a little freebie. How about yellow? Zoom. Pull out 4x again, and what does that leave behind?
X squared.
Minus
9x.
plus 18. And yet again, we look for, can I factor it? And the answer is, I sure can. What does it factor down into?
X minus 6.
Yeah, nice job. And then I can scroll and say, woof, we made it. And so, start looking for all the big fish. So x plus 6's jump out right away. X minus 6's jump out. X minus 1's jump out.
4x.
4x's.
4x's can cancel if you want to get in a lot of trouble, right? Remember, they're both bottoms dwellers. You can't do that. And again, if you want to start navigating, like if you're good with fractions, you don't have to do my whole dumb collected up thing. Just FYI. Okay. I just, having worked with people like yourselves for a long time, know that it's kind of nightmarishly hard for when everyone in the room is looking at those 4 numbers and like, oh, well, could I divide it? Well, yeah, well, could I? It's like, yeah, there's could I have. At the end of the day, I just think it's easier to just collect it back up. So what's 8 times 3? 24. What's 4 times 4? 16. And then let's go through and gather up any free range x's. How many do you have on top?
X cubed.
Got 3 of them on top. How many on bottom? Good. You see?
And then
Just gathering up all the simple things. And again, you could be crossing things out right now if you would prefer. I know I've said that like 3 times, but I don't care. So 24 and 16 can both be divided by 8, which leaves our answer with definitely a 3 and a 2. How many x's will be left and where will they be? Just 1 x is left over. And then you just put everything back in that didn't die in the big massive slaughter. I think that's it for the top, right?
Yeah.
We're just missing an x minus 3 on the bottom. So, got it? You want to go again, or do you want me to be
Could we
done?
redistribute and then get rid of the X's?
No, because then this x is still going to be a part of a subtraction. So like if you do 3x over 2x minus 6, it's still part of a subtraction problem, right? So we got it all, every drop. We'll go again. Okay. Let's do one more. Let's see if we can finish one more. I got two more. Let's do, oh, they both look so much fun. Let's do this one. How can I possibly be expected to choose?
Oh, boy. Oh, that's not them. 7x cubed just to the and
100.
really. Or,
Yeah, he is calculating. He is calculating.
there's no way you did that.
There's no.
You guys should be writing this down and not carrying on with your criticism of poor Landon there. Well, that's a 14. Just doing it more quietly doesn't make it any less stalling. I don't know why teenagers think when adults tell them to stop doing something that they just do it quietly, they're following direction. It's an odd sort of thing. All right, I'm gonna pour some coffee while you get started. I'll color code it and catch up to you in a second. What's gonna happen on that top left?
7X. Wow.
Yeah, you're gonna pull out that Gary Charles Franklin, right? That GCF. And if you pull that out, so red guy gets a 7x pulled out, and what's left? X squared
Oh,
minus 100, right? So I thought I'd go a little quicker this time. You all know the difference of squares, factors like that. So if you don't want to write x squared minus 100, I'm not encouraging you to make bad choices. Just if you can skip a step, you might as well. Be a little more careful maybe on this next one, the purple one. I can pull out 14x cubed. What's going to be left when I do that?
X squared
Uh-huh.
and then.
So you want me to write x squared and then 4?
Minus 3.
Well, then why didn't you say minus 4? So x squared minus 4. And what is that going to become? Yeah. So I was going to write that until Parker made me use English. So x plus 2, x minus 2 is the factorization of that. So again, let's head up here to the northeast. What'd I do? I didn't do anything. Were you going to say that that 4 looked like a 2 looked like a 4?
exactly. They do look like.
Yeah, I don't know what happened to my pen. I got shaky. Upper right, green guy. What do we do?
4X right.
4x to the 4th. What's left over?
Minus 14.
Nice job.
And the cube is 3, is 4 rectangle.
No, doesn't really. I don't think there's a word for it. Can we factor down the green thing?
Yeah.
What is it?
X minus.
X plus 7, x minus 2. Good. And then finally, Mr. Yellow. Pull out 2x squared, leaving behind.
Plus 10. Slide 30.
No, just minus 30. We already got the x's. What does that factor down into?
10 3
Mhm.
plus 10 plus 9.
So you say to do 2x squared times plus 10 minus 3. Did I get?
Plus 10, x minus 3.
Oh, I don't know why you guys don't just say what you mean. So x plus 10 times x minus 3. It's weird. I just think I'm like a mind reader. So again, let's cancel out all the heavy lifters or the heavy hitters, and then we'll go back and regather. And I kind of did this one differently so that maybe we can avoid the regathering, but we'll see. This was not an accident. So X plus 10s by X minus 2s by. God, what a lame problem. Who wrote this? So do you notice anything? I'm just going to throw this out. What's 7 times 4? What's 14 times 2? What's 28 over 28? So I can really just get rid of all the numbers because they're just crash course to cancel anyways. Can we agree? How many X's do you have on top? I got 1 and 4. Hey, how many do you have on bottom? So those just all cancel out. So I just kind of did this on purpose. I wanted to get one where maybe it felt like a little bit less of a pain at the end, right? So all the X's are just canceling it. Hey, zip it up there, truck boy. So what do we get?
Oh, X minus 10. X plus 7.
Over.
X plus 2. X minus.
Yeah, that really wasn't as much fun as I thought it was. I really thought I wrote it better. I got to try better. I'm going to write a new one for fifth hour. That one is 2 thumbs pointing 30 degrees down. I didn't enjoy that. I thought I'd enjoy that more. So I don't know. Assignment 47 is on Delta Math. It assigned itself about, I don't know, an hour or two ago. Beats me. Tomorrow I'll give you a nice chunky work day. I'll probably throw a practice quiz at you tomorrow just because some people will say, I wish I had the practice quiz so I could study over the weekend. And then there'll be some people who say, I'm not going to study over the weekend. Whichever group you're in, that's your concern. But I think I'll throw that at you tomorrow too, so you can have a whole bunch of stuff to do. Sound good? Lena, you doing okay? You good?
Oh,